My name is Diana Egorova. I'm from Tokyo University of Agriculture and Technology in Japan, and the topic of my poster is the impact of hyaluronan size on localization and solubility of the extracellular matrix in the mouse brain. Our study is focused around hyaluronan, or HA, in the extracellular matrix of the brain, where it forms dense insoluble aggregates called perineuronal nets, or PNNs, around the subtype of inhibitory neurons. HA acts as a scaffold for HA binding molecules, chondroitin sulfate proteoglycans, or CSPGs. PNNs stabilize synapses and play a role in memory formation. Besides dense PNNs, HA is also distributed throughout the brain as a part of diffuse ECMs. In this work, we employed the HA molecular weight analysis method that we developed to look into the potential difference in HA between PNNs and diffuse ECMs. Key findings of our work are that HA in the insoluble fraction of the brain, which is known to contain PNN's components, is of a significantly higher molecular weight than HA in the soluble fraction. To further confirm that PNNs contain insoluble HA, localization of soluble and insoluble HA in the brain was assessed by staining brain sections pre-washed with Triton buffer to remove all but insoluble components. We found that insoluble, higher molecular weight HA was mostly co-localized with PNNs, while soluble, lower molecular weight HA was present throughout the tissue outside of PNNs. Overall, our work showed that higher molecular weight, longer strands of HA form insoluble PNN aggregates, while shorter HA forms less dense ECM throughout the brain. From the data not shown here, we also found that fragmenting these long strands of HA in the insoluble fraction leads to increased solubility of this whole aggregate. Thank you for your attention.